Good day, doctor. We are from Group C. My name is JIUN. I will start my presentation. So, for the title is Predicting Housing Price Using a Neural Network Model. Next. Introduction. Objective: build a deep learning model to predict housing price. So, what it matters? It helps home buyers, investors, and policy makers. The data set we use is California Housing Dataset. So from the technique we use MLP, and we use Python, TensorFlow. Next. The goal is accurately predict median house value based on census data. The challenge is missing value in total bedroom, target variable kept at 500,000. School distribution in features. Risk of overfitting in neural network.
Salam sejahtera, Doctor. My name is XIAN. So continue to my part, data analysis. This graph shows the prices of all houses from our dataset. The x-axis is the house price. The bars show how many houses are at each price. Look at the graph. We see a lot of bars showing different prices, but look all the way to the right. This is a very tall bar at $500,000. This looks strange. This means that any house with a price of $500,000 or more was just recorded as $500,000. This is a limit or a cap. This is not the real price for those expensive houses, and it can mess up our analysis. So we need to fix this. We remove all the houses that were listed at exactly $500,000. Our original dataset has around 20,000 rows. After we remove the cap values, our dataset is reduced to 19,000 rows. So we remove about 1,000 rows. Now look at this new graph. The giant spike on the right is gone. The data look more natural now. Next, this is another type of chart called a box plot. It is help us to understand the prices. The big blue box in the middle show where half of all the house prices are. So most typical house prices are inside this box. The line inside the box is the middle price. This is the median house value. The line upcoming out of the box show the range of almost all the other house prices. The black knot on the right side are houses that are much more expensive than the rest. We call these outliers. This block plots confirm what we saw in the last graph. Most houses have prices in the middle range, and a few are much more expensive. Next, this chart called a heat map. It helps us see how different pieces of information in our data are connected to each other. Each box shows the relationship between two things. The color tells us about the connection. Dark red means a strong connection. The number in the box is close to +1. The dark blue means a strong opposite connection. The number is close to -1. White and light colors mean there is little or no connection. The number is close to 0. So look at the boxes or total room, total bedroom, population, and households. They are all very red when compared to each other. This just means that districts with more rooms also tend to have more bedrooms, more people, and more households. So this is logical. Thank you.
Good day, Doctor. My name is HENG. So my part is deep learning model design. So this slide outcome the architecture for the multi-layer perceptron model designed from a regression task. The model task 30 input features passes them through two hidden layers of 64 neutrons, each with the relay activation. Apply 20% dropout for regularization and product a single continuous value from a one neuron output layer with linear activation. For the training process, the training method is model fit with the batch size 32. Validation speed is 20% of the training. Early stopping, patient 10, train 20 to 30 due to the early stopping, and the callback use is model checking point and the early stopping. For the evaluation metrics, represent the final evaluation of the deep learning model. Showcase its performance and on unseen test data using key regression metrics. The model achieved a mean absolute error MAE of approximate 0.19, and most importantly, the R-square score of 0.77. The R-square score indicates that the model can successfully explain about 77% of the variance in the house price data, demonstrating a strong prediction capacity. The positive result on the test set suggests that the model generalizes well to new unseen data without significant overfitting.
Good morning, doctor. My name is Thim, and I will present the result. The first one is the plot for the prediction with the actual plot. So we can see here the most of the point line is close to the diagonal line. However, there is a slightly under prediction, which is like here and here, not consistent. So here said we have slight under prediction in high value homes and slight over prediction in low value homes. What is the reason? So because we use the log transform, it can compress the scale, but apart from that, we get the diagonal much more consistent. Next is the training loss curve. So we can see here the line is much stable, and here that validation loss closely follows training loss, and we have get the early stopping trigger around the opportunity, and thus we can conclude that there is no overfitting and it's stable convergence. So that is my part. Thank you, and I will pass to my team member.
My name is Kenny, and I'm to continue my part with the predicted house price versus the median age. So from the plot that we can see, the relation type, the predicted price show a non-linear relationship with the housing median age. This is a scatter plot around and the line plot here. And we start from age 0 to 20 first. Age 0 to 20, its predicted price are relatively stable or slightly decreasing, as you can see like this in the curve. These houses may be seen as past their prime but not old enough to gain a uniqueness. There are also some may be possible contributing factors such as outdated features, maintenance needs, or market perception. And then we start at age 20 to 30 years. We can see that it's a sharp decline in the predicted prices. And start from age 30 plus to the maximum here. The price begin to rise again after reaching a minimum around rise from 30 to 50 around 20 years here, and it indicates an upward trend for older houses. Newer houses, especially the very new that really brand new, tend to have slightly better, higher predicted price because it is new. Of course, the new houses will be higher in the term of price. So last but not least, for the conclusion, multi-layer perceptron NLP is effective for a structural regression task, and proper pre-processing and architecture data are important in our through this our project. And we can know that after run output, we can know that deep learning models can generalize when trend in the condition of when trend the data trend correctly. And this project lays foundation for real deployment of further enhancement. I think that's all for me for my part. Thank you.
Good morning, doctor. So I will present the demo part for the code. So we use the Google Colab to do the code. First we import the library, and then import the data and cleaning. So the data is here, the output. Next, we do the result of the graph. So here you can see this is the overfitting, and then we try to modify it until not overfitting like this, and then we put more consistent, and then this the result for the heat map. This is the box plot for the overfitting here. And then next is this the feature engineering. We need to prepare and transfer the raw data into a format that is more suitable for training machine learning or deep learning model. So it just transform raw data into that format, then the model can easily to train. So here is the model, and then we compile it and do the model training, and then we evaluate it. So the evaluate here is the test MAE is 0.118, MSE is 0.07, RMSE is 0.26. So the R square score is accuracy is about 0.77. So it's like accuracy is 77%. So this is the output prediction code. And then here is the result just now we presented. So the report here, and then this is the result of our predicted. So that's all from my presentation. Thank you.